Okay, I started the recording, so please, the floor is yours.
Okay, great. Well, thank you for having me. So a couple of years ago, I found myself using my Commodore 64, and I'm not a someone who memorized all the Jiffy DOS shortcuts and commands, and I wanted to explore some of the advanced features of the SD2IC. And I was constantly looking up the different DOS codes and commands and all the syntax for that. And I thought, okay, you know what? I'm just gonna make a little program to make those things a little easier. And that's kind of where this started. And it just kind of got out of control, I guess. So what it evolved into was, after some enthusiasm from the community and sharing it with the Toronto Pet Users Group in Toronto, Canada, I decided, okay, I'm gonna try to make this the best, most polished, usable, I can share this with people and feel good about it as I possibly can. Make my best effort to do that. So and basically what this is like, it's inspired by, let's say, Amiga DOS, MS DOS, Linux terminal, and it's a command line interface for the Commodore 64. So my name is Chiron Bramberger, and I named it chiCLI. And I'm going to turn on screen sharing, and we'll take a quick tour. Okay, so does everybody see my desktop?
I can see it.
Okay, great. So this is the GitHub page for it, and we will minimize that for now. And I'm going to go ahead and drag the chiCLI disk into Vice. I'm using Vice to ensure that this demo goes smoothly, because right beside me is a 40-year-old Commodore 64, but I wanted to make sure that that everything went smoothly. So, okay, so here we are. This is how it boots up. And I'm just going to run the Sysinfo command, which is what it runs on startup, just so that you can see it one more time in full screen. So here we go. This is what it looks like when you first start the program. And there you go. So I tried my very best to recreate the chirp from the Commodore PET. So some of you might recognize that. You can even type in the chirp command if you want to hear it again. So what we've got now is a couple things. Hopefully you can see my mouse pointer here, but basically this is like NeoFetch on Linux. It's trying to detect hardware. Now, I only officially support machines as they would have come from Commodore, and I try to support beyond that as best as I can, but this is not intended to be like a robust, super duper hardware troubleshooting diagnostic type of thing. It just tries to identify your machine and show it. So at the top, it's identified that this is a Commodore 64C, but it's also identified that it's running in Vice. And it's detected that it's running in NTSC. It's detected that there's Jiffy DOS, but it's the R3 kernel. And again, when you're running a C64C, you have the MOS 8500 CPU. It's running at 1.02 megahertz, and that is detected. I can talk about that later. And the graphics processor there, that's the right one for the Commodore 64C. And there's our Sid detection. Of this, the Sid detection is using the best method for looking at a Commodore Sid chip and determining if it's the 6581 or the 8580. If that is the basis for a lot of the hardware detection. So at the moment, if you have a non-standard system, or if you're using ARM-SID or SwinSID or something, it may not totally detect what model of Commodore 64 it is. And if that's the case, it's just going to say, okay, it's a Commodore 64 and it's a MOS CPU and it's using a VIC-2, but it won't have more detailed information. Now, just to be clear, I've written this in the C programming language using the CC65 emulator, and I've done that for two reasons. Because it's harder. So specifically, you can program in BASIC and you can program in assembler, and you can do great things in assembler and you can do fast things in BASIC, but doing things in C is tougher than assembler in some ways, because even though some people might think that programming in C is easier, programming in assembler lets you get down to the hardware level. I wanted to do my best to develop my skills at interfacing with the Commodore 64 through C at that hardware level. In addition to that, I also wanted it to make me a better C programmer. So that's what the motivation is. Having said that, in the future, I'd like to improve the hardware detection. I'd like to directly detect the VIC instead of basing it on the SID and then assuming that the machine is either a 64 or 64C, for example. I want to directly detect the hardware chip. I found assembler code to do that. I just haven't implemented it in C. And I'll talk more about that later. But the short story is every version of this program that I release is completely full, meaning it fills up all available or nearly all the available memory on a Commodore 64. So every time I've added a new command or a new function or a new feature or a new hardware support, I go over the 64K, or it's about 52K that you can get away with. And so I have to go and optimize the program. So that has also made me a better C programmer, hopefully. And that's part of the process. So that's why there are a lot of features that are implemented the way they are, or things that I haven't implemented or haven't refined. For example, like really great error messages, because it would just take up too much room and I'm always running out of room. So anyway, here we go. So again, the Sysinfo command goes through when you first start it or when you run it, and it goes through the devices and it detects what devices you have. Here we have device 8 is Jiffy DOS and a 1541. And then this is device 9. This is a CMD hard drive running DOS here. I picked these two devices because CMD hard drive, like the CMD HD, is what the SD to IEC was modeled on. And so it's the best way to emulate having an SD to IEC device. So the first thing I'll show you is the help command. And when you run the help command, it displays some help. And one of the things it shows you is that you can type in help commands to get a list of commands that you can then search for help on. And so here's our command list. So I'm going to go through it very quickly, and then I'll show you some of the essential commands. But basically, we've got 1571. That allows you to put the 1571 drive into double-sided or single-sided mode. The / is a little complicated. I'm going to leave that for later, but basically it lets you run a program from within chiCLI, but you can also send it command line parameters. And that's part of the feature of CC65 is you can launch a program either from BASIC or from another program and send them command line arguments. But that's a little bit, that's a rabbit hole we'll go down later. The @ command here, this is very much, it's a shortcut, not entirely, but basically a shortcut for the DOS command. So the DOS command lets you run a specific DOS command if you want to send a DOS command to a device. So for example, if you wanted to send the DOS command V, that would run validate. So that's how you would use the DOS command to do that. I created this shortcut for people who are used to Jiffy DOS shortcuts so that they can send something like this instead. That's all. So it's a shortcut for the DOS command, but it works a little bit differently because of that. The equals command, that's basically a quick little math command. About tells you more about the program. Alias, the system has aliases defined, and I'll show you that in a moment, but it's similar to Linux or Amiga-DOS. The CD command changes directory. Chirp, you saw, makes the little noise. Clear, well, that clears the screen. Color set, it lets you pick the specific colors you want for the display. Convert is a number conversion thing. So if you're peeking and poking in memory, this will let you convert between decimal and hex and show something in binary, things like that. The copy command, it copies files. The date, date time, and time command all display the date if you have a real-time clock. So for example, the command HD does have a real-time clock. Some SD2ICs have a real-time clock. I actually bought the chip and the oscillator for mine and installed it, and so I have that on mine as well. I'll show you that. The date delete command deletes a file. Disk copy, that's for dual drives like the Commodore 4040 or the super disk drive MSD SD2 drive. I have one sitting here. It'll copy directly from one drive to another within the same device. So this just is a shortcut for that. The DOS command I show you lets you send any DOS command you want to the device. Drive detect runs the drive detect is the same command or the same function as when you run Sysinfo and it detects all the drives. So this is just that as a command. Drive set lets you change the device number of a device that you're using or drive. So if you wanted to make your SD2IC respond to device 11 temporarily, you can use drive set to do that. It's more of a temporary stopgap. Some of the way that the program works right now is once you change the device number of a device, it can't detect the drives anymore because it doesn't know what's assigned to what. So it's sort of like, okay, you temporarily change the device name, you do what you need to do, then go and restart the program and back to business as usual. But it's a convenience. Dump mem, there's actually a view mem command and a dump mem command that allows you to look at memory. The dump mem command allows you to save that to a file. So if you just want to save a block of memory to a file, it'll do that. Or you could even save the kernel ROM. The echo command is exactly what you would expect it to be, just echoes text. Exit gets out of the program. File date shows you the date of files when they're supported by the device, like the SD2IC. Format's a floppy disk. Help, you saw. Hotkey is for assigning things to the function keys on the Commodore 64. ID64 is a hardware command. It lets you turn on or off write protect if you have an ID64. The init command sends the initialize command to the device. Key codes lets you see what keys you type in. It shows you the key code. I'll show you that. LD and its alias LP are for list drives or list partitions, and it shows you the partitions on a device. So for example, Command HD and SD2IC have partitions, and this lists them so you can change them. The list command is like the directory command. Directory is actually a short form for list, but it displays it a little differently. I'll show you that in a moment. Make directory makes a directory. Mount is if you're using the SD2IC, you can mount a disk image that way. And I'll show you how you can extract files from a disk image. Well, we'll see what we have time for. But if you have an SD2IC and your SD card has two partitions on it, you can use one partition, mount a disk image, and then using my program, copy those files to the second partition on the same SD card. The part command is just another way to change partitions, and I'll show you how the CD command and the partition command allow you to navigate your different drives and partitions. Peek is like peek. Peeking does it over and over and over again if you want to look at changing hardware values. Poke is similar to the DOS basic poke command, but this isn't trying to replace basic or Jiffy DOS or anything like that. So it works without a comma, but other than that, it's a poke command. Profile loads a color profile. PWD, that prints the working drive and directory. Reboot reboots your machine. Relabel changes the name of a disk. So if you have 1541, you put a disk in, you want to change the label and the ID number, or not number, but the ID code. Relabel does that. Rename renames files. Remove directory removes an empty directory. Run runs a program. SD2IC allows you to change certain settings, so you can change whether or not the SD2IC shows extensions or hides them. And if you change your drive number with drive set or DRV set, then you can save that as a permanent drive letter change using the SD2IC command. Shuts down your machine. I'll show you that. It's pretty cute. The speed command is what actually is run when it so when you start up and you run Sysinfo and it shows you the speed in megahertz. It actually does execute a no-op payload and attempt to time how long that takes. And so it is real. It's not just, oh, everything's just outputting the correct text and because I know it ahead of time. It's not a perfect benchmarking and it's not intended to be. So what I do is when the math is kind of on the edge, I take a range of values and go, okay, it's probably this speed or that speed. So for the common speeds of common machines like Super CPU or Commodore 64 or Commodore 128, it will output the speed that it's supposed to be if the results are, within 1 or 2 values of the range that they should be for that. If you're running, let's say, an Ultimate 64, I believe it will show you the different speeds because there's like 5 or 6 different speeds that the Ultimate can run at. So it's real, but it's not, a benchmark, and you shouldn't use it as such. SS is for screensaver. It shows a little logo with the time or the CPU temperature. That's right, we're getting there. Status gives you the drive status. Stopwatch, I have that assigned to a function key, but basically you run it once, it starts a stopwatch. You stop the stopwatch by running it again, and it tells you how long it's been. I think it has a few hours that it'll go. I forget what the limit is. It's in the help file. Super CPU, that allows you to actually turn on or off the super CPU acceleration if you have a super CPU. The sys command is like the basic sys command. It allows you to jump to a point in memory and start executing. Not super useful, but can be somewhat useful. But most of the time, it's going to screw up the fact that chiCLI is loaded and running and doesn't expect you to go willy-nilly in memory and start executing stuff. But for example, if there are some situations where that's useful, probably more of a debugging tool. Sysinfo you saw. Temperature, I'll show this at the very end, but this displays the CPU temperature. That's right, no extra hardware, no nothing. It'll figure it out. Time, again, shows the time if you have a real-time clock. The type command is like in DOS, it types a text file, and I'll show you that. The help command is also just typing text files, so it's similar to the type command, but the type command will also display things in hex. And if you have a basic program, it'll actually read the basic program and reinterpret and output the basic text. So it'll look up the basic tokens and actually output the text for that. Unalias allows you to unassign an alias. Unmount lets you unmount a disk image. Validate sends a DOS validate command. And viewmem, like I said, lets you poke around memory and view it in a hexadecimal table. So what should we start with? Well, the first thing you can start is, so you start the program, you get this neat little screen, it's fun. And then you go, let's say, instead of list, I've got many common shortcuts, so I'll go ls. And now we're looking at the files on the chiCLI distribution disk. Now, if I type in ls/l for long, it'll give me this output, or S for short will give me the short version. Directory is basically a shortcut to that. So typing directory, and that's a 2-column view. It doesn't show you the file sizes, but it takes up less screen room, so that can be helpful. Now, if you want to change devices or directory, you can go CD. Now, if you remember from the opening screen, I had another device set up. So similar to the Amiga, this is how you can change to a different device. But instead of DF0, we're going device D09 and then colon, and now you're on that one. So this is our CMD hard drive. So what I can do now is, and again, there are aliases and shortcuts for common commands. So instead of make dir, I can actually just go MD. And let's say I'm going to do this. So I'm going to go like that. And now you can see I've created that directory. Now, if I go CD, chiCLI, disk, now I'm in that directory. Great. So if I want to copy some files, I can then go back to drive 8, which is our 1541. And I can, well, actually here, if I look at the sizes, I don't want to waste your time. So what I'm going to do is I'm just going to copy chiCLI help, and I'm going to use this command here. So that's autocomplete. So if you type in control and the left arrow on the Commodore keyboard, that does an autocomplete, and it's gone through our directory listing and found the first match. So now I don't have to type the rest of that file in. And if I want to copy that, I can just do this. It's going to go to the directory that we were last in, similar to the way MS-DOS works. So if I go like that, it's going to detect the file. It's going to copy it. It's only 1K in size, so it's pretty fast. And now when we go back there, that was a typo, but I actually correct for several typos because the Commodore 64 keyboard doesn't do anti-ghosting or NT rollover. So some of the very common typos, if you see them go by and it still works, it's because I automatically correct for them. But here we go. There's our sequential file. So I could also, if I wanted to, go back here and see, instead of CD, I just typed in C, because if you press C and hold it down and press D, it won't register that. So that's the only shortcut. That's a one-letter shortcut for the CD command. But anyway, I can go copy star, so everything, and I can now copy that to the other drive. And it'll say, are you sure you're going to copy 9 files? And I can go, okay. Now, this is going to take a long time. So I'm actually going to press Control C or run stop, and it's going to get out of there because I don't want to waste your time, watching this thing copy files for a few minutes. So there we go. Now, if I go to the next drive and I go, okay, great, I've copied a file, but you know what? This program file, I know it's 5K, but I know the original file, is 48K. Oh, right, because I stopped copying. Let's go ahead and, well, why don't we rename it? And ren is a shortcut for rename. There you go. So I'm going to rename chiCLI. And in fact, let's use that autocomplete. So if I go C, oh, it's picked the first one, so I can just back up and do that. All right, so I'll just do that. But again, we've got that. I'm going to rename chiCLI to chiCLI and incomplete. I see. Sure. So when I list it, I've changed the file name. And again, this is all about taking advantage of muscle memory. So I'm used to Amiga DOS or MS-DOS or even Linux terminal commands and things. And I wanted something that was easy to remember than Jiffy DOS. So this isn't, my attempt to create a whole operating system or to replace Jiffy DOS. It's a terminal. It's a command line interface. So I'm going to go ahead and delete it. That's great. Now let's say I just want to delete everything. I can actually go delete star, and it'll do that as well. So there we go. Now, if I want to list partitions, I can do that. And it's going to go and it's going to show me the 2 different partitions here. So in this case, because I'm in the folder chiCLI.disk, it's listing that as the disk name. But you can see here, if I actually go back, now I'm in the root folder. And if I go list partitions again, it's going to give me the name of the current folder, which is the partition name in this case. So if I want to switch to a partition, I can do it a few ways. I can go like this, and then I can go partition A. And now I'm in partition A. Great. But let's say I want to go to partition B. I can go like this. And now I'm in partition B. And if I wanted, there's nothing in there for now, but here, why don't I make a directory and I can go, this is part B. And then when we do a list, we can see, okay, great, we're in part B. Now, if I want to quickly switch to partition A, I created a shortcut command for that, which I like. So there it is. So I can go partition B, and then go back partition A. Now, if I want to change devices again, I can go to device there like that. Whoops, whatever, it worked. And I can also directly type in just this, and it will go directly there. So if you don't want to bother typing in CD for changing devices, you can skip that. But I obviously can't just type in chiCLI disk because that's a folder. I actually have to go into the folder. So if you press up, there is a command history. It goes back about 5. 5 is a good balance between gobbling up memory, which is measured in individual characters and bytes. And I found that 5 was extremely useful. So I can go back and I can grab a previously entered command. So let's say I do the validate command. Are you sure? Yes. All right. So now it's processing the validate command. I'll do it one more time. I'll press up, right? Because I can go through my command history. So press up. Are you sure? And you can see there's some drive activity down here. So that's run the validate command. If I go init, it's going to do the same thing, and it's going to do that. Now, if I love Jiffy DOS and I love the shortcut, here, I'll just do this again so you can see this. I'll use this Jiffy DOS shortcut and I'll go V, and it's going to run it right away. It's not going to ask any questions. So that's one of the differences. So there you go. So that is that command. Now, if you want to change devices without typing something in and use the Jiffy DOS shortcut Control D, that will do it. So here we are, device 8. Control D cycles to device 9. Control D cycles back to device 8. So that's a shortcut that's friendly for people who like Jiffy DOS and sort of have that muscle memory going. Let's see here. Now, I'm not going to show each and every command because that would make this very long. But the idea is that you can do all of the file management stuff that you would do on more modern systems, and it's more comfortable to do so. So you can copy files, delete files, make directories, rename directories, copy files from different devices, stuff like that. So let's show some of the other things here. If I show alias, this is a list of aliases. So for example, if I wanted to set my own alias, let's see here, how many slots? I've got 8 slots and there's 1 free at the moment. I can clear all those slots, but these are the default ones. So I could go, let's say alias, and we'll go hello. And then I can do this. I can go echo, hey. And now when I type in hello, it does that. And there you can see at the end, there's the aliases. Now, hotkey. So hotkeys, just a short form for hotkey. So hotkeys shows you the available hotkeys, and this shows me the various features. If I press, for example, function 5, it starts the stopwatch. If I press it again, it stops the stopwatch, and it shows me it's been 3.2 seconds since I did that. Likewise, if I hit F3, I can clear the screen. If I hit F1, I can do a list. If I hit F6, it's going to run Sysinfo again. And if I hit F8, it's going to show me that help file again. Now, the help system is dependent on having these help files right here in the folder that you're currently in. So if you go to another device and those help files aren't there, it's not going to work. You'll have to go back to the device and do it that way. This is because I want people to be able to copy just the program to a disk or a cartridge or whatever and use it without worrying about having all the files and whatnot if you're memory constrained or whatever. I'm also working on a printed manual, and I can talk about that later, but the idea would be that you could have a nice printed manual on your desk, and that would help you use it. So let's see what else I can show here that's fun and exciting. So the date command shows the date, the time shows the time, and date time shows the date and the time. If I run the screensaver, by default, it shows the date and time as it's being pulled from the RTC on the systems that support it. Now, actually, I can use the shortcut. What else can we show everyone here? Let's see. Showed you the delete command. Basically, the DOS command just lets me send, for example, the validate command, and that should work unless I've got that wrong. Maybe that's a little, oh, validate, that's going to take a while. Sorry about that. Let's go to warp mode, wait for it to be finished. Maybe I got that wrong. Good news, I can just restart it, hence why I'm using Vice. My apologies. But whatever you enter into the DOS command, it'll just send it to the device once it checks that you're sure you want to do that. So you have to know what you're sending. So If I go drive detect, it's going to detect the current drive. Let's see. Dump.
Is one question available?
Hello?
Can you show type with a text document? Have you a text document there?
Yes. So I will list some of the files here. So there's a README file. So if I go type chiCLI, use autocomplete, README, and now it's printing out the content of the text file. Now, if I do help for type, there are some options. So one of the things I can do is H, and that's going to give me a hexadecimal view of the file we just saw. And so now you can see we've got the hex and the character numbers here, and then here's the content we just saw. And if I had a basic program, I could show that. So if I do this, now this is a machine language program, but you can see if we were to list this in basic, that's what we would see is 800 sys 2061. And it also shows the header and the footer codes of the basic file. And let's see. So what else can we show here? Oh, yeah, file date. So if you have an SD2IC or command HD, I can go file date and it'll, oh, right, because this is different. I think I need to do, let's see here. Oh, right. Okay, I can show this. Sorry, the 1541 doesn't support file dates, obviously, so that's why that didn't work. But what I can do is to show you the output of that, I'm going to copy chiCLI, just the help file, just one of the small ones, to here. It's going to copy the file. I'll do the command D, switch to the device, list it. Now if I go file date and autocomplete, it shows that that's the day and the time that the file was created. So that's pretty fun. And let's see, what else can I show you?
This is all very cool. Can we look at temp real quick?
Not yet. No, we're not done.
Okay.
I'm saving that till the end. But thank you. I appreciate the enthusiasm. So key codes, that just shows me the key codes when I type things. That's exciting. It's good for development. We saw a lot of this stuff. If you want to peek, you can do a peek, but peeking, actually, here's what I can do. I can go like this. And then peeking runs over and over and over again. In this case, this is color RAM, and these are the unused color RAM lines. So that's kind of the exciting part for that. So if you're poking around in memory and you want to see a changing value, that's what that's useful for. This shows you we're on device 8. We're on the first partition. It's only got one, and that's the name of the disk. If we do a list partitions, we can see there's only one, and we can see the disk name here and then the number, but I can go relabel, and I could go, I could call this test and TC, TS, TT, there we go. Are you sure? Yes. So it's relabeled the disk. If I do a list, you'll see it's now called test. And if I go list partitions or list drives, you'll see it shows test and TT. And if I want to change it back, I can do this. And then we'll see that it is back to the way it was. Great. And what else? The run command, you just type in like run chiCLI, but there's also help. If I load the help for that, if you have Turbo Macro Pro, it will actually load Turbo Macro Pro and then run the system command to run it from memory. So for example, you could type, I don't have Turbo Macro Pro in this disk image right now, but run Turbo Macro Pro, if that's the name of the file, or if it's just TM or whatever, TMB or P or TMP, I think is what it's usually called. You go run, you know, TMP and then /T, and it automatically uses this to run it. So that's a nice shortcut for Turbo Macro Pro users. The speed command spits that out. And I think the view mem allows you to view memory. It starts at the beginning of memory, but you can also start somewhere else. And if you want to dump memory, you can, and then you can specify, you know, where in memory you want it to start or stop. Or I have a shortcut, so you can go ROM kernel, and it'll dump the kernel to a file. I'm not going to bother that because it'll take a while. So finally, if I run the temperature command, now this is an emulator, so it's only going to show 41 degrees Celsius, because what Vice does is it uses what I think is the common value that's output from a Commodore 64 that has a heat shield, because I've noticed that if you let it run for a little while with the heat shield on, that tends to be the temperature. So I'm sure the big question now is, well, wait a minute, how is it measuring the temperature? So I'm not the first person to think of this, but I couldn't find anywhere any programs online that did it. I'm sure it's got to exist, but I wanted to do it myself. So what happens is there are some unused pins on the Commodore 64. Let's see if I can show you here. This might help. I don't know if we can focus. Here, let's see if I can just, where is it? Stop screen sharing. Okay, so if you can see me, I'm going to show you some schematics. So right about here, so this is the 6502 on the Commodore 64, 6510, sorry. And it's got these P3, P4, P5 pins, and they're used for the cassette motor stuff. Well, that register in memory has some unused pins. And the thing with those unused pins is they're not connected to the package at all, but they do exist on the die. So if you turn a pin on, sorry, if you set the pin to be an output and you turn the pin on, it's going to go high. Now, if you switch it to output and immediately start reading it over and over and over again, eventually, due to the capacitance of that line, it is going to stay high for a while, and then it's going to drop off. And the time that that takes is dependent upon the temperature, like the capacitance of the CPU die and of that pin, and whatever capacitors are on the die is such that when the temperature is lower, it takes longer for the value to go from high to low. And when it's warmer, it's much more, it's faster. So if I go back to my screen sharing and we do this, I can run this in a debug mode. Just gives me more information. So in this case, it's taken 18,000 CPU cycles to do that. And it's also taken 0.3 seconds. And so I do two measurements. I do one measurement using the time of day clock, and I use another one that uses, does it use raster time? No, it just counts cycles, I think. Yeah, it just counts cycles. Actually, let's take a look here. Maybe I can find it in the code here. So this is on GitHub. I'll show the link later. But print temp. So if we go into the code here, here are some conversions that I do. And where is it? I believe it is time of day clock. Yeah. And then Yeah, it counts cycles. Yeah, that's right. Okay, great. We can get out of here for now. So what happens is if it takes too long, it needs to count it in seconds because it can be quite a few seconds. When it's like 10 degrees Celsius, it takes like 4 seconds. After it starts warming up, you have to measure it in cycles because it doesn't take as long. But one of the neat features of the screensaver is that you can go, it is what, enable temperature? No, temperature enable. No, let's enable temperature. No, I was wrong. It is temperature enable. And now when it runs as a screensaver, it'll show you your CPU temperature. So this is all well and good, but if I stop screen sharing, I may be able to rotate my monitor around and show you on some real hardware. So just to show you here, I've got the real Commodore MSD SD2, and I've got the monitor here. And we're going to try to quickly, while the machine has been off and it's cold, if I can quickly do it, I'll be able to show you here. So here we go, load. See, this is what sometimes happens when I'm running Jiffy DOS and the SD2 at the same time. It fails at first, but then it works. I don't know why. Part of the reason why I use device. So here it is running on real hardware. And if I go temp, you'll see it says 21 degrees Celsius. So if I go like this, no, sorry, wrong one. Now you'll see the temperature is going up because it's running. And in fact, if I were to run the temperature command, in fact, here's what I'll do, hotkey, and I will set it to hotkey number 7, and I will go temp with debug mode. And now every time I hit F7, it will run with debug. I know it's not great in terms of quality here, but this says temperature 26, cycles 24,000, and so seconds 1.7. So if I run this over and over again, you'll see that the time is going down and down and down. It's just a little hard to, it's a little bright. I don't know how to fix that. Does that help? I don't know if that helps or not. But in any case, if you can see that, it says now it's at 29 degrees Celsius. So I've tested this with my thermal camera, and that's where I developed the lookup tables for these values. And if you're interested, again, you can go to the GitHub page, which you can find on my GitHub. So that is, so Chiron B on GitHub, and then chiCLI. It's chiCLI, not chiCLI, absolutely not chiCLI ever. chiCLI, and all the source code is there. I don't have a make file, I just have a little make script. It doesn't, I haven't done it on Windows yet. Maybe at some point I'll make a Windows one, but it's pretty straightforward. If you poke through things, you can figure out how to do it. And yeah, all the source code's there. It's GPL. So if you're in the program itself, you can even go version, and it'll show you within the program, the GitHub link, and it'll even show you the license and when it was compiled, the date and time and everything. So there we go. I think that's a pretty good overview.
Perfect. Thanks a lot, Karen. I think there were a couple of questions. One of them was actually the link to or the URL, but you just gave it back, and it's also on the agenda. So for people looking on the Commodore User Europe web page, you have it there.
Great, and I'll paste it right now.
Yeah, that would be perfect. And I saw, how well does this work with Pi 1541?
It works well. I don't have a Pi 54 one yet, but I know someone that has been helping me with testing. And if you actually, here's what I'll do here, one sec. If I go back to screen sharing, if you look on the GitHub page and you scroll down, you'll see here's a bunch of quotes from people who are very happy with it. And if you look under hardware, so on real hardware, the Command HD and the Pi 1541 was supplied by this person. Raj did a great job. Thank you very much. And this has notes for people who have helped with the testing, and we'll give you some notes. The other thing you can do if you want to know about hardware is if you type help, you'll see one of the shortcuts is actually for a different mode of operation for help. You can go help and then hardware, and that will show you the hardware that's supported. And it has some notes. And if you want, let's say, even more information, so you can go help SD to IEC and then -H for hardware. And it's going to pull up a different entry from one of the help files, and it'll show you which commands are supported and which are unsupported. And that's separate from command help. So for instance, if you go command SD to IEC without the -H, it's just going to give you the entry for the command called SD to IEC, which executes the special SD to IEC functions.
Really nice. I see a lot of nice comments like, I like this, I want this. That's pretty good. I don't think that there are more questions in the chat, but I have a few. I think at the beginning you mentioned, so okay, it's detected like NTSC or C64C, etc. So it's not in the configuration. So when you run it on the real hardware, it will also detect. How on what is that based? You make an inventory of the chips, or how do you get to detect the real hardware?
Yeah, sure. Well, I can even show you a little bit too here. If I go into the source code, let's see here.
Or you can just explain. I mean, just looking at the time.
No, sometimes I need the reminder too.
Okay.
Let's see. So if I go to the Sysinfo command, it runs a bunch of other commands. So the first thing that it does is it detects the SID. And based on looking at the SID, it can figure out if it's the 9-volt or the 12-volt. Like, so the Commodore 64C or the 6581 original SID. It doesn't detect any other kinds of SIDs at the moment. I'd like to add support in the future, but again, I gotta find more room somewhere, which means I'd have to optimize. So, and it uses that to determine if it's a 64C or a regular 64. And based on that assumption, it's going to then assume that because it's a 64C, then it's going to be this VIC and et cetera, et cetera. To detect NTSC, I look at there's a byte in the kernel, and whatever you found online is actually not correct. I found the best byte. There is one byte in the whole kernel, which is really good at detecting whether or not it's an SX64 or what version of the kernel it is. Again, this is all in the source code. Like if it's an educator 64, whatever, there's one byte that is the most unique byte in the kernel for determining that. So that's how I detect the kernel. For NTSC, I used to use the kernel to detect it, and I can't remember. I think I still use the kernel to detect it, but there are better ways to do it. That was just the shortest way to do it, so I could fit as many features in as possible. It also looks at so it looks at the kernel, it looks at the SID, it looks at, for example, it'll detect if it's a the C64 mini or the 64 versus Vice. And that's because both Vice and the C64 or the C64 mini set up RAM in a default pattern. So I look at the pattern of RAM and then use that to determine, for example, if it's emulated under Vice or not. Now, in Vice, you can set the memory pattern to be, and in fact, I talk about this in the code right here. But if you look at Vice, there is an option you can use to change memory to whatever you want. So if you did that, then you very much could obviously trick my program into not knowing it was being emulated. So again, it's not bulletproof, and that's not the goal, but it's pretty good. It'll detect SX64, Educator 64, all the different PAL, NTSC, C64, C64C, the earliest C64s. If you're running on a 128, it will, in 64 mode, it'll detect that it's a 128, or if it's a 128D, or if it's a 128 DCR. What else? It detects MR as emulated. I don't have a MR. I know someone who's helped me test it with the MR. So it usually just comes up, I think it comes up as Vice. I'm not sure. If I had a MR, I'd poke around and find a better way to reliably detect it. But so I use a variety of tricks. And again, I try to come up with the least amount of code, the tightest way to do it possible. So again, I can fit in as many commands and features in as possible. Oh, and by the way, the 64 that I've been running right here, you can see is now at 40 degrees
40
Celsius.
degrees.
So it's been slowly getting hotter and hotter. Fun fact, if you don't have a heat shield on it, it can be, it can get as high as like 65 degrees Celsius, and the spec sheet says it shouldn't be hotter than 70. So, you know, having something to, at least the heat shield or something might be a great idea. But I didn't realize how hot it would get if it were completely naked and nothing was going on. So, and the accuracy is a couple of degrees. It's not perfect, but it's pretty good. I'll probably refine it. I recently had to fix a bug, but the temperature detection, it works a lot better than I thought it would.
Okay, good, really good. Maybe another question. So now it looks really like a subset of commands that we have normally in the shell or something. Is it possible to write? Because I mean, the day-to-day usage of it would be like manipulating files and these kind of things. Is it possible to write batch files and to use pipe? Like if I want to read the content on a certain memory allocation and dump that into a file or something like that. Can I do that? Is it possible to use pipes and these kind of things?
Right. So that's a two-part question. So the easy answer is I wrote a command that will dump memory to a file, but at the moment it doesn't use pipes or run batch files. However, I had that in mind from the beginning. And so perhaps I'm at version 1.06, I think right now. Maybe a version 2 might have the ability to run a batch file. I'd like to be able to do that, but again, every version I release is maxed out in terms of RAM. Like if I go in to fix a bug and I do like one printf statement to barf out something for debugging, it'll be like, nah, you ran out of memory, and I got to go disable some command or something to temporarily make room to debug it and then fix it. And then if I still have enough memory, great. If I don't, I'll have to find somewhere in the program I can optimize something or make a little room or something like that. So so it would already have the batch file thing if it were easy to have more room. But no, the pieces that are needed to do the batch file thing, I think most of them are there. It would probably be a numbered kind of batch file. So it would, you'd have to put line numbers in the batch file. I think that would be the easiest way to do it, but maybe not. Anyway, it's on the horizon, no promises, but it's definitely something I'd like it to be able to do, but it doesn't do it at the moment.
Okay. Oh, good to know. Then we will follow this project on your GitHub page. I don't see more questions. I think for the moment. So thanks a lot.
Thank you.
I think I will then close the not close, but stop the recording. And now, where is this? Is this here? Okay, I stop the recording now. In case there are more questions coming, maybe people put it in the chat, and then you can retrieve it from there.
Sure. Sounds good.